In this video, we're going to talk about proportions, ratio tables, and unit rates. The reason that these all go together is because they're all basically about equal fractions. So they're all about being able to compare different fractions and recognize if they are equal or not. So if I think about a proportion is just a comparison of two ratios. So a ratio is a comparison of two numbers. A proportion is a comparison of those two different ratios. So if I use something easy like 1/2, I can say that that is a proportion. I can make a proportion of 1/2 to 2/4 to 4/8 to 3/6 to 50/100 to 25/50 to 30/60. I can do lots and lots of proportions for 1/2 because there's so many different ways that I can make a half. So just kind of considering all of these, any of these would make a proportion. So let me use this first one and this last one. So I have 1/2 equals 30/60. What I would want to think about is what am I multiplying by to go from this number to this number. The only way that I can convert to make equal fractions is by dividing or multiplying. So for instance, if I had 50/100 equals 25/50, what I'm doing is I'm dividing by 2 to go from 50 to 25, and then I divide by 2 to go from 100 to 50. I could also look at that as 50 to 100 is multiplying by 2, and 25 to 50 is multiplying by 2. I don't add or subtract to make equal fractions. That wouldn't work, because 50 to 25 I would be subtracting 25, but to go from 100 to 50, if I only subtracted 25, I would get 75. That's no longer an equal fraction. So I can't add or subtract to get different numbers. I must multiply or divide. So when I look here, I think, okay, 1 to 30, that's pretty easy. I need to multiply by 30 to get to 30. And then here, from 2 to 60, multiply by 30. So whatever I do to my numerator, I have to do to my denominator, and that's how I get that proportion. Let me show you a ratio table now. So a ratio table is sort of like what I just drew with all of my 1/2s, but I make it vertically instead. So I could have like X and Y or A and B. If I were talking about cats to dogs or rainbows to butterflies, it wouldn't matter what my categories were. I'm just looking to see that the ratios are the same. So let's just say that we have dogs and cats. And I have 1 dog for every 2 cats. So 1 to 2, or it would be 2 to 4, or it would be 3 to 6, it would be 4 to 8, 5 to 10, 6 to 12, 7 to 14, and I just keep counting up that way. Now, I should be able to notice a couple of patterns here. I should be able to see that this to this to this is always increasing by the same amount. So down this side, each time I'm adding 1. Down this side, I see each time I'm adding 2. And I also should be able to see some sort of multiplication going on. So if I think 1 to 7, I get there by multiplying by 7. To get from 2 to 14, I also multiply by 7. That's important to notice because it's not always going to be something easy like 1 to 2. What if I have a ratio, it's a little bit harder, like 2 to 5. Still not really difficult numbers, but I am going to need to figure out how that works a little differently. So I'm counting by 2's over here, 2, 4, 8, 10, 12, 14, and then over here I have 5, 10, 15, 20, 25, I made a mistake. I forgot my 6. So now I can see, okay, to get from 2 to 8, I had to multiply by 4. This same row, 5 to 20, I also multiply by 4. If I go 2 to the 14, I multiply by 7. 5 to the 35, I multiply by 7. So each kind of row helps me realize that there's connections between each row, and then there's also connections on either side. Now, the thing about ratio tables is often in testing, they mess with you a little bit and they'll skip rows. So let me go back to that example of 2 and 5. And let me just go ahead and see. I can think about what this might look like. So it might give me a couple of examples on the left, and then, you know, maybe it gives me only one example on the right, or a couple of examples. So I know that this is a 2 to 5, and I see that I add 2 this time. The problem is that it's skipping all the way to adding 4 here, so it's not going by the same amount. So that might throw me off because I don't see that it's missing this 6 right here. Same thing between 8 and 16. I don't see that I'm missing 10, 12, 14. I'm missing all of those numbers in between. So when I go here on this side, if I just purely count by 5s and do my 5, 10, 15, 20, and think, you know, great, good for me, I counted by 5s. Now I think that 16 to 20 is right. That's not following the same fraction. So there's a way that I can test that. If I really think that 16 to 20 is equal, I can look at this and think, okay, so if 2/5 to 16/20 is equal, what am I multiplying by to get from 5 to 20? I multiply by 4. What am I getting to get to, what am I going to multiply by to get from 2 to 16? I multiply by 8. So that is not equal. That's an unequal proportion because I'm not multiplying by the same thing or dividing by the same thing to get to the other fraction. So I want to be careful. I can also cross multiply to figure out and do 5 times 16. Does that equal 20 times 2? And it does not. So I could also follow that way. So I want to be careful with ratio tables. There's usually going to be some kind of blank spot or one where I need to figure out, okay, so now here, what if this side is 20, then what is this side going to be? So I need to be able to figure those pieces out. So it can help to make a better ratio table where I have all of the numbers and I'm not skipping any to make sure that you're not making any mistakes. So what's a unit rate now? So a unit rate is where the denominator is 1. So I'm figuring this out per unit. So something like 60 miles per hour is a unit rate because it's 60 miles per 1 hour. That would be the same as I could make a proportion with that and say that I'm able to travel 120 miles in 2 hours. But this is the unit rate because of that 1. If I have something like, a whole bunch of candy that I'm trying to split between my friends, we're trying to split it up, then I might say, I need to find a unit rate. So I have, 60 pieces of candy per my 5 friends. So what is that going to be for just one friend? 12 pieces of candy. Because I'm thinking 5 divided by 5 gets 1, so 60 divided by 5 equals 12. So what would this number be? Or I could even look at this. Remember, I can read fractions as division, so I can look at this as 60 divided by 5, and then I would get 12. Just like if I go back to this problem, if I do 120 divided by 2, I get 60. So that's how I look at unit rates and ratio tables and proportions. It's all just different ways to look at equal fractions. So different ways that you're simplifying fractions, looking at how something is equal or how something is not equal. So having a really solid foundation of understanding equal fractions is necessary to this kind of math